So for the global class,
Mhm.
where they have vectors, so they go from this one, does it just go just push and pull?
Yeah. So this is just gonna, it's almost like a plunge. It can go in and out like that.
Okay.
But whether you include that in the analysis is up to you. And so actually, when I did this myself, I was kind of more concerned with the structural integrity of the walls. And so I actually just suppressed kind of everything here. And so that's one thing that you can do too.
Yeah.
But if you are interested in working with the plunger, then that's you can do that too. But I actually just took it.
Yeah, I tried to stretch all the bolts and
Yeah, that's a good idea. Yeah. Mhm.
and then it just says when it goes in, it moves a lot, then you cannot remove it as well.
Mhm.
So I was thinking if I change the inlet outlet radius,
Mhm.
maybe that's a good way to start.
Wait, oh, you're changing you want to change the geometry?
Yeah. Okay.
I would keep the geometry. Yeah, and so I'm not asking you to do any kind of design for this one. I just want you just to do the analysis.
So this will be like a water outlet to outlet.
Yes, correct.
And the main thing will be the water pressure on the walls.
Exactly. Yeah.
Right. And do I have to worry about this? I think there's layers in the
Yeah, so there's going to be an outer diameter and an inner one. And so, most of the boundary conditions that if you're talking about water pressure is going to be applied on the inside.
Okay.
And so it's going to be a little bit hard to click on the inside. And so what you can do is you can hide places. That's kind of the thing. And so I'll show you how to do it on Monday, but it's actually pretty easy to do. So all you have to do really is just kind of click and highlight faces.
Yeah.
And you can click multiple by doing control click. And if you right click, there's an option there for hide faces. And I think actually the hotkey for that is F8. But for me, I usually just right click and click that.
Okay.
And so with that, then you can gain access to the interfaces, and then you can apply pressure to that conditions.
So the pressure will be will be pressure, force, actually will be pressure.
Yeah. Mhm.
Okay.
Yep. Mhm. All right, so today is an Ansys day, and so if you want to start up Ansys Workbench, then we can get started right away. So we're doing activity 4. All right, it's 5:30, so let's go ahead and get started. Good evening, everyone. How's everyone doing today? Wonderful, great, good. You're having a better day than I am. I'm feeling tired. Yesterday, I was driving home, and I guess I wasn't paying attention. I was kind of tired, and I was making a left, and I kind of ran over the center divider a little bit, and then my left tire just completely just blew out. So my entire left tire was kaput. And so I have a picture on my phone. It's kind of gnarly. Maybe later, if you're interested, I can show you on my phone. But it was the worst tire incident that I've ever had. I had to replace it with a spare. But I made it here. I'm safe, and so I had to drive side streets because I'm driving on a spare tire. But just how it is sometimes. Okay, and so today we're doing our next Ansys activity. And so it's basically based off what we talked about on Monday, which were shell and beam elements. Okay, and so in the activity today, you're going to get a chance to try it out in practice and to learn how to actually incorporate these types of elements inside your Ansys simulation. Okay, and so if you haven't already, I would go ahead and launch Ansys Workbench. And then we can go ahead and go from there. Okay, it is a little bit of a longer activity, and so a fair bit of it today is going to be just kind of watching and following along. But if you can get past, I think the first part of the activity where you actually make shells and beams, then I think you're going to be in good shape. Okay. And if you notice the due date for this activity, it's a little bit longer than the usual, and so I'm having this due not next Friday. So traditionally, I usually have it due the Friday after we do the activity. I'm pushing this all the way up until we do our next one, which is the following Wednesday. And so you guys have about 2 weeks to complete this activity. Just because it can be a little bit lengthy. So and I know this is kind of busy times for everyone where midterms are happening and projects are happening, and so I want to give you guys a little bit more flexibility for this. Okay. Any questions before we get started today? Okay. All right. And so the geometry that we're going to be working with is basically a bridge. Okay. And so a couple of years ago, I found this CAD model for a bridge on GrabCAD. And I thought it would actually work really well for this activity. And so, the original GrabCAD author is credited here. Okay. But luckily for us, he created a geometry that actually wasn't that well suited for finite elements. But it's actually kind of a good thing for this activity because it'll show you kind of a lot of what you need to do to clean up this structure. Okay. And so the whole idea with this activity is that, if you look at the geometry for this bridge right here, we have a lot of geometrical features that are thin and slender, right? And so if you look at the two sides of the bridge, right? So these are fairly thin. And so if you compare the length of the bridge versus the height, and then you compare that to how thick this bridge is in this direction, okay? It's extremely thin, right? And same thing for the other side. And then this road right here is actually a very thin sheet as well that we can model with the shell element, okay? And then there's a lot of slender elements here as well, because we have this structural beam that occurs up here. And it's a little bit hard to see, but on the bottom, we also have some supporting beams down there too, okay? And so there's a lot of aspects to this geometry that work really well with shells and beams. Okay? And so if you want to read this introduction section here, this is a little bit of a summation of what we talked about on Monday, okay? And so I'm not going to go through it again, but it's there if you want. Okay? If you want to look at the summary of kind of what we're going to go over today is, we're going to use another program called Spaceclaim, which is included within Ansys. Okay? And so Spaceclaim is kind of the premier CAD software that Ansys is trying to promote. Okay, and so it's the more modern one. Okay. We're also going to learn how to create shells using the mid-surface operation that we talked about on Monday. Okay. We're going to extract beams, okay? We're going to clean up our geometry. And so what you'll find is that after we perform our mid surfaces and our extractions, then our geometry is going to be in not the best state, okay? And so we're going to need to clean it up a little bit. And then we're going to run the simulation in Ansys, okay? Okay, and so first step is going to be to convert our geometry into shells and beams, okay? All right, and so if you haven't already, let's go ahead and open up Ansys. And let's go ahead and create a static structural job, okay? And then in the geometry, you can go ahead and load in the bridges.igs, which is a CAD file that you can download from the website, okay? All right, so does everyone have Ansys open and they've imported the bridges geometry here? Okay. Right, and so once you imported the geometry, we're gonna go ahead and model this inside Spaceclaim, okay? And so don't jump to model yet. And so we're gonna start with geometry, okay? And so the default program here should be Spaceclaim. And so if you double click geometry, it should open it up in Spaceclaim. But just to make sure, you can go ahead and right click on geometry. And then we're gonna click on this button right here called Edit Geometry in Spaceclaim, okay? And so there's quite a bit that we need to do with the geometry first before we actually apply meshing and boundary conditions and all that stuff, okay? And that's gonna be the main part of the activity today. All right, so I'm gonna go ahead and click this, and it's gonna launch a new program called Spaceclaim. And I believe this is our first time seeing this in this class. Okay.
Double click on the geometry, same thing.
It should, yeah. So the default CAD software should be Spaceclaim. Yeah. No, I don't participate. All right, so it does take a little bit of time to start up, especially if you're probably working on a personal machine, okay? But eventually you should be able to load in this program here, okay? And so you can see, it looks similar to Ansys Mechanical, but the interface is clearly different, okay? And so, once you've loaded in the geometry, then it should look like this. Okay. All right, so was everyone able to open up Spaceclaim and get the geometry to the state right here? Okay. All right, and so now we're going to start the process of converting everything to shells and beams, okay? And so this geometry is unique in that, basically every single part of this geometry, every single solid here can be converted to either a shell or a beam. And so, once we're done with this, we're not going to have any solid elements left at all, okay? All right. And so, before you start, converting things to shells and beams, it's always a good idea to kind of, look at your geometry and just kind of take a second to kind of plan out what you want to do. Because, you'll see in a bit that once you start, converting the geometry to shells and beams, it goes a little bit fast, and it can be, you might lose some geometrical features. And so, take a moment to say that, let's say that, we have this side of the side of this bridge right here. We know that this side of the bridge here is pretty thin. And so we're going to want to replace this with a shell. Okay, same thing on the other side. And then same thing with the road down here too. Right? And so the road, you can see, is a very thin surface. And so this is something we can convert to a shell as well. Okay. And then all of the supporting beams, this top one here and all the bottom ones, right? So all of these are fairly slender because they're much longer than they are wide or tall. So we're going to convert all of these to beams. Okay. All right, and so now that we have our strategy down, let's go ahead and start, converting this geometry. Right? And so before you do anything, it's always a good idea to try to repair your geometry first. Okay. And so the first thing I'm going to go to is I'm going to go to this tab up here called Repair. Right. And so what this will do is that this will allow us to it'll allow Spaceclaim to find any kind of geometrical features that it can kind of fix right away. Okay, because what can happen sometimes is that, especially if you inherit this CAD model from somebody else, it might not be the best CAD model in the world to use for finite element analysis. Okay, And so there's some automated tools that you can do in order to repair it, in order to kind of get it to a nicer state. And so, before I do anything in Spaceclaim, I try to use these automated tools just to try to catch any errors. Okay. And so the two in particular that we're going to use are going to be stitch, okay, and gaps. And so what these two features essentially do is that they search your entire CAD assembly for any kind of weird gaps or any kind of weird places where it can kind of stitch things up, before we actually start converting things to shells and beams. Okay. And so to use these tools is very simple. So all you have to do is just click stitch. Okay. And then if Spaceclaim can find anywhere where you can actually stitch the results, it'll show it here. Okay. And then this green check mark right here, okay, this will be non-grayed out. Okay. And so if you click stitch and then this green check mark is not grayed out, then you can go ahead and click the green check mark, and then it'll automatically fix any regions that you have in your geometry. Okay. And so for this particular case, we don't have any stitch areas. And so you can see after I click stitch, there's a kind of a notification at the bottom that said no areas found. Okay. And so that's a good sign. And so at the very least, there's nothing for us to stitch together. But this is always not a bad thing to check for any geometry, just because it's so fast. Just click repair and you click stitch, and it'll check those things for you. Okay. All right. And so the next thing we're going to check for are gaps. Okay. And so you can read the tooltip here. So this feature here will detect and fix any gaps in a surface body. Okay. And so we go ahead and click that. Okay. And you can see here that it found one area, right? And so it's highlighting it in red. And let me further highlight it with my pen right here. Okay. And so it found this kind of weird gap in this geometry here. Okay. So let me go ahead and click it again. Okay. And so to fix this gap, you can go ahead and click this check mark right here. Okay. And so normally what that'll do is that'll fix the gap here. But because this geometry was not designed for FEM, this gap is actually kind of a weird kind of a stick thing that's on there. And so eventually we're going to suppress this, but if you click this check mark and it says no problem areas were fixed, that's okay. That's okay for this one. And so it won't actually fix it for this time, but for other CAD geometries, if it does find any gaps that it can fix, this will kind of fix it for you. Okay. And so in the end, for this case, we ended up not fixing anything. But this is always something good to check if you're going to be working with Spaceclaim, right? Especially if you're going to be doing any kind of shells and beam stuff. Okay. All right. Any questions on this so far? Okay. All right. And so the next thing that we're going to do is we're going to create shells. Okay. And so remember, the way that we create shells is we do a mid-surface operation in between in between parallel faces. Okay. And so in order to do a mid-surface, let me go ahead and move this a little bit. We're going to go to this tab right here called Prepare. Okay. Right, and so Prepare will have a lot of the operations for us that that we're going to use to fix this geometry. Okay. And once you go into the Prepare tab, you'll see that there's another button here called Mid-Surface. Okay. And that's the one that we're going to use. Okay. All right, so let's go ahead and click the Mid-Surface tool right here. Okay. And then let's start by making a mid-surface of the two sides of the bridge. Okay. And so the way this works is that you're first going to click on one of the parallel surfaces. Okay. Right. And so remember, in order for a mid-surface to work, it has to be two surfaces that are completely parallel to each other. Okay. And so the two surfaces I'm going to pick are the inner side of the bridge. And so I'm going to click it. And so after you click it, it's going to highlight for a second, and then it's going to disappear. Okay. Then I'm going to click the other side of the bridge. Okay. And once you make that second click, you'll see that it's going to highlight both of the sides a different color, right? And so the first surface that you click is going to be highlighted blue. The other one's going to be highlighted green. Okay. And at this point, you want to make sure that your two faces are indeed parallel. Okay. And so if they are parallel and you're good to go, then you can go ahead and click on this check mark right here. Okay. And then after you do that, you can see that, we've created this mid surface, right? And so the original three-dimensional solid body that used to be there is now grayed out. And then in its place is this thin shell, okay? And so if you actually left click anywhere within the window, you can see now that we have the shell of what it used to be. Okay. Right. Question? Oh. All right, so was everyone able to create this first shell right here on one side of the bridge? Okay. All right, so let's go ahead and do the same thing for the other side. Okay. And so your mid-surface operator should still be highlighted. So let's go ahead and click this. And I'm going to click the other side. Okay. Right. And then we're going to do the same thing for the road. And so for the road, we're going to click on the top surface of the road and then the bottom surface. Okay. All right. And so now we've created all of our mid surfaces. Okay. And so now your geometry should look something like this. Okay? And so we have shells that replace the two sides of the bridge and the road. Okay. All right. Any questions on this so far? Okay. All right. And so that's the mid surface operation. Okay. And so that's how you create shells. And so that's pretty straightforward. And so the next thing we're going to do is we're going to extract the beams. And so let's go ahead and go to the Prepare tab again. Okay. And then this time, what you're going to click on is this small button right here called Extract. Okay. Okay. All right, so let's go ahead and click Extract. And so what this will do is that this will allow you to click on slender parts of your geometry and then convert them into beams. Okay. And so the way it works is very simple. So the only thing you have to do is click Extract. Okay. And then you're going to go to a slender part of your geometry. And so let's take this top part here. And then all we're going to do is just click it. And then after you do that, then you can see it just transforms into this thin line. Okay. And then, whambo bambo, and then we now have a beam. Okay. And so we're going to do the same thing for all the supporting beams on the bottom. Okay. So just go ahead and click all of them. Okay. And there we go. And so now we've converted our geometry to shells and beams. All right. And so that was easy, right? And so, that doesn't seem so bad. But if you kind of rotate your geometry around, you should see that we have some issues, right? And so let's look at kind of this part right here. Okay. Right. And so in the previous geometry, this line right here used to be kind of a supporting beam on the top, and it used to make contact with this side of the bridge. Okay. And you can see that after we've done our mid surface and after we've done our extraction, that's no longer true. And so we don't have these two connected. Okay. And so that's going to cause issues later. So if we load this into Ansys Mechanical right now, then we're not going to be able to form a connection there because they're not actually touching each other. Okay. And so we need to make it so that each all of the parts that should be connecting are actually connected. And so this happens often. And so, when you kind of eliminate kind of the thickness of certain materials, then it's going to cause some other parts of the model to not match up. Okay. And so the nice thing is that there's a feature within Spaceclaim to account for this. Okay. And that's called the Extend tool. Right? And so under Prepare, we're going to go to this tool right here called Extend. Okay. And so it's in the kind of in the top middle of the program. Okay. Right. And so if you kind of hover over it for a second, then you can read what the tooltip does. Okay. And so what this does is that it extends surface edges and sketch curves such that they intersect bodies that they should be. Okay. And so we're going to go ahead and click on Extend. Okay. And what you'll see right away is that it'll say that there are no areas found. Okay. That's because our tolerance here is only 10 millimeters. Okay. And so what the program is doing is that it's looking for any surfaces that are within 10 millimeters of each other, or it's looking for basically any 10 millimeter gaps and then it's going to identify those in the program. But because our bridge is a little bit bigger than this, we need to make this gap a little bit bigger. Okay. And so instead of 10 millimeters, let's go ahead and increase this to 50 millimeters. Okay. And so you can see after we've increased this to 50 millimeters, it's identified, several regions in our model where it can extend, extend this to the wall. Okay. All right. And so everything that's covered in this kind of red cloud right here is going to extend. And so let's go ahead and click on the check marks. Okay. And you'll probably have to click it more than once. Okay. And you can see after doing that, then our beams are now extended into our bridge. Okay. Yeah.
There's a few areas on that model where it's not highlighted.
Yes. Yeah, that's supposed to happen. And so it was like that for me too. And so there should be some beams that even after you do the extend tool, it doesn't recognize that it should be extended, but it's supposed to do that. Yeah. And I'll show you why in a second. But let me just do a quick check for now. So was everyone able to extend at least some of their beams into the bridge? At the very least, the top one here. Okay. All right. And so, like Jacob mentioned that, there's still some beams that aren't connected. And so if you kind of hover over the bridge like this, you'll see that there's still some gaps, right? And so you can see that these three beams right here are not extended into the bridge, okay? And the reason for that is that after we applied our extraction, these lines are actually not even lined up with the bridge itself, right? And so if you can kind of view this from here, okay? And so I'm viewing this I clicked on the Z direction here, okay? You can see that there's a gap, right? And so this small dot right here, it's a little bit hard to see. So this small dot is the beam that we extracted, okay? And you can see that it's not even within the plane of the bridge, which is this region over here, right? And so what Ansys is doing is that when you click extend, it tries to extend this this beam as far as it can until it reached another surface, but there was just no other surface for it to intersect against. And so what we need to do is we need to take this beam and actually move it up towards the rest of the bridge. Okay. All right. Cool. Okay. And so we're gonna manually move this beam in the Y direction such that it actually starts to intersect with the bridge. And actually to make this a little bit easier, I'm gonna go ahead and hide the road. Okay. And so if your road, I think it should be the third one here. Okay. And so I'm gonna uncheck this just so that we can just hide it for a second, just to make it easier for us to perform this action. Okay. All right. And so in order to move these beams, we need to do a couple of things. And so we need to know how far down it is. And so we need to do a measurement, okay? And then once we've measured how far down it is, then we need to manually move it up into the until it's on plane with the bridge. All right, so first thing we're gonna do is we're gonna click on measure, okay? So we're gonna click on the measure button up here, okay? And then we're gonna click on measure, this other measure button right here, which is the measurement tool. All right. And so with this measurement tool, you can measure distances, very easily between different parts in your model. Okay. But before we do that, I want you to activate this setting right here. Okay. And so this setting right here is called Show XYZ Vectors. And so what this will do is that we want to find specifically we want to find out what the Y direction distance is between this beam and the bottom of this bridge, okay? And so we want to split basically the distance in between those two. Okay. All right. And so with the measurement tool highlighted, you're going to hold down Control on your keyboard, and you're going to select. You're first going to click on the beam that's not extended all the way, okay? And then you're going to click on the lower edge of the bridge. Okay. Oh, did not do it. Measure. There we go. Okay. Right. And so by clicking those two, you can see that, from this image right here, that the distance between the beam and the bottom of the bridge is about 1.9221 millimeters, okay? And so that tells us that we need to move this beam upwards in the y direction by about that amount, okay? And so I want to move it up a little bit extra just to make sure that it intersects with the, intersects with the bridge, okay? And so let's go ahead and remember this number right here. And so, through the power of Zoom, I'm just going to write it down over here, okay? 1.9221 m. Okay. All right, and so now that we have that that number, okay, let's go ahead and move this beam upwards. And so to move objects, you're going to click on the Design tab up here, okay, and then you're going to click on this button right here for Move. Okay. All right. And so let's go ahead and click Move. Okay. And then after you click Move, you can then click on the beam that you want to move. Okay. And so remember, this is the beam that we want to move. Okay. And then we want to move it in the y direction. Okay. And so check to make sure that your directions are lined up. Okay. Because we want to move this back towards the bridge. And so in this, for my case, the y direction is this kind of blue arrow right here. And so you're going to click and drag on this arrow. Okay. And you can see as you click and drag the arrow, then you can move the beam up and down. Okay. But we only want to move it a certain amount. And so, go ahead and click and drag it just a little bit just to make the window show up. Okay. And then in this window right here, you're going to manually put in the amount that you want to move it up. Okay. And so remember my distance here was 1.9221. And so I'm going to move it up 1.923 just to make sure that it intersects with the bridge. Okay. All right, so I'm going to go ahead and hit enter. Okay. And so now the beam is moved up, and so it should be intersecting with the bridge right now. Okay. And so if we go back to prepare, and then we go to extend, okay, you can see now that we've moved the beam upwards, now Ansys is saying, okay, now I can see that these two, should be connected to this to the side of the bridge. Okay. And so we can then click the extend tool, and we can go ahead and click OK. Okay. Right. And so now that beam is successfully extended and making contact with the bridge where it should be. Okay. All right. So was everyone able to do that for this beam right here? Okay. All right. So why don't you guys go ahead and work on the other beams? Okay. And so there should be 3 more that need work. Okay. And so there's the two right next to that one on the end. And I think there's one more on the other side. Okay. All right, so go ahead and follow that same process. And so remember, you have to measure what the distance is. Okay. Because each beam is different, and so the distance between the beam and the bridge is different for each one. And so you can't just use 1.9223 for each one. And so make sure you measure for each one. Go ahead and move it up, and then extend it. Okay. All right, so I'm going to do it really quick on my end, just so we can go ahead and keep moving, and then I'll walk around and help people out. Okay. But let me do it really quickly on my end.
How far above should we go?
You should get it so that they basically they basically just kiss each other, and so move it just the minimum amount up such that they just barely enough to intersect. If you're having trouble, just go and raise your hand and ask. I'll come. Yeah. So that was that's something that I'm actually not sure what that is, but we'll suppress it later. Yeah. And so normally you would you could fix gaps like that, but I'm not even sure what that is. But normally you would fix it. But for this one, we're just going to ignore it and suppress it.
Okay, thank you.
It's under prepare. Yeah, I don't know. I honestly, I've run this activity just the third time now, and I don't know what that is. It's some remnant of the guy who created this. So we're just gonna suppress it. So I'll go to geometry. Sorry about that. And, I'll go and right click this one. The question. So that's that surface. We just go and right click this one. So, yeah. And then you're going to click the other one. So you're basically clicking on both surfaces. It looks like it's selected one of them. Try clicking down instead of yeah, it looks like it definitely selected one. You want to try it on the this computer? Normally try with the so try with the road. With the road, yeah. Go ahead and click on volume. Go back to this. Oh, that's fine. Oh, I see. Oh, okay. Yeah, you have to click on this. I think automatic. Go ahead and click the velocity. Yeah, it's definitely just one of those. Oh, there you go. Yeah, and so go ahead and click the check. Okay. So you gotta do that again for both sides. Yeah. You have a mouse and you can use that. Okay. And with the mouse you can rotate easily by holding down the middle. Then you can save the left. Yeah, unfortunately, it's one of those things that looks that's a little bit easier. But if you want to use the trackpad, then I guess use it. Oh. Did you when you moved it, did you just move the one side or did you click on the entire thing? Looks like they're both. I see left on both. Oh, that one's good. You can try to undo. So you can try just to undo some operations and just add yeah, try undoing the and then try clicking on the whole. Yeah. That's fine. So go ahead and click on the whole beam. And just move down. I think you probably just put it one step. Or click on the arrow. You can undo. Yep. Yeah. Okay, I know some people are still working on it, but I do want to, because there is quite a bit of the activity we have left to go. And so I want to make sure that we get to a good point. But if you are kind of, ahead, I know some people were kind of looking at the PDF to go ahead, and that's totally fine too. And so if you want to keep reading the PDF and keep moving ahead, that's good. Okay. All right, but I'm gonna go ahead and keep moving forward. Okay. And so the last thing we have to do here is we have to make sure that the road is actually lined up with the bridge too, because right now the road is just kind of floating in no man's land, right? And so the road too, we're gonna have to move downwards, okay? And just like the beams, we want to align the road with the bottom edge of the bridge, okay? And so we're gonna do the same thing that we did before, and so we're gonna do some measuring, okay? Except this time we're gonna measure the road, okay? And then we're going to measure the bottom of the bridge, okay? And you can see that the wide distance between them is 28.3735. Okay. Mm. All right, and so I'm going to go ahead and move this road down. But this one, I'm going to stop it a little bit short because I don't want them to go below the beams here. I just want to get it as close to the bottom of the bridge as possible. Okay. So I'm going to go ahead and click design. I'm going to go ahead and click move. Okay. This. Go ahead and move it down. Okay. And I'm going to move it down 28.37. Okay. All right. And so you can see now that the road is basically sitting right on top of the beams. Okay. And so now we're going to go to prepare. And then we're going to click extend, okay? And you can see here that there's two more surfaces now that can be extended, okay? And so we're going to extend basically the side of the road into the bridge, okay? You can actually do that with just one click, okay? All right. And so with that, our geometry now is now set, okay? And so we've created this, we've converted this geometry into shells and beams. And then we've basically cleaned up the geometry such that all the parts that should be connecting and touching each other are actually touching and connecting to each other. Okay. All right. Any quick questions I can answer before we go ahead and pop this into mechanical? Okay. All right. And so if you've gotten to this point where you've connected the road to the sides of the bridge, we can go ahead and close Spaceclaim. Okay. And so from that point, you're going to be back in Ansys Workbench. Okay. And then we're going to open up Ansys Mechanical by double clicking on model. Okay. Okay. I don't know why it's doing this. Okay.
Double click the project or just click the project?
Yeah, double click on model in the project. And so
No. I was saying, I think your thing's not popping, just click project. And I think your geometry will pop up.
Oh.
In mechanical.
Yeah, I think it's still moving. It's almost there.
That's what yeah.
Okay. All right, and so if you once you've loaded up into Ansys Mechanical, you should see your bridge and it's all of its flat glory. Okay, and so from here, first thing we need to do is we need to suppress this tiny little twig thing that I'm still not quite sure what it is. Okay, but the nice thing is that it's kind of appearing here as its own surface, and so we're going to go ahead and right click this and then just suppress it. Okay. And so the name of that surface should just be sys/surface, okay? Right, and so we just went ahead and suppressed that, right? And from here, we have to do a few things first before we start to actually mesh and apply boundary conditions, okay? And the main thing is that right now, because we've converted everything to shells and beams, Ansys has no idea about what part should be connected to each, and so we need to manually add in all the connections into this geometry to tell Ansys which part should be bonded to each other. Okay. All right. And so we're going to be spending time here under this connections tab. Okay. And we're basically going to create manual connections that connect the different parts of this assembly. Okay. All right. So first, let me go ahead and right click on connections and then go ahead and hit insert. Okay. And then you're going to click on manual contact region here, okay? And so what this will do is this will allow us to define a contact region between two different bodies. All right. And so you can see here that, now we've pulled up this new menu here, okay? And then in order to define a manual contact, we have to define the contact surface and the target surface, okay? And so basically these are, the two parts of the geometry that should be in contact with each other. Okay? All right, so we have several contacts that we need to make, okay? And so the first thing that we want to make sure is that we want to make sure all of our supporting beams are in contact with the, with the side of the bridge, okay? And so let's go ahead and select all of the sides of the beam, okay? And so I'm going to go ahead and switch to Vertex Selection mode, okay? I'm going to hold down Control on my keyboard, and I'm going to select all of the points here on the bottom of the beam, okay, or the bottom of the bridge. Okay. Okay. And so there should be 8 of them in total. So 1 on top and then 7 on the bottom. Okay. And then once you've selected all 7 of those, under the contact of your of here, you're going to go ahead and hit Apply. Okay. And then after you hit apply, you can see that the contact is now 8 vertices, which are the 8 sides of the beams that you just selected. Okay. All right, and so that's the contact. And so now we have to define what surface that those beams need to be in contact with. Okay. And so that's going to be the side of the bridge. Okay. And so now I've switched to face selector mode. Okay. And so now we can select a surface. And so now we're going to select this side of the bridge like here, okay? Yes, we just need 1 click like that. We can go ahead and hit apply, okay? And now we've created this contact region which defines all the sides of the bridge, all the sides of the beams with the corresponding side of the bridge. Okay.
For each side, right?
Yeah, you have to make another one for the other side as well. Yeah. All right. Any questions on this? Yeah.
Is it the same to just select both sides of that surface?
Yeah. So you have to do them separately because you can only define kind of one contact per. And so if you want to do it for the other side of the bridge, you have to create another contact region. And so you can go ahead and right click here and go ahead and insert and another manual connection group, and then you'd have to do it for the other side as well. Because the contact surfaces are different because one side of the bridge is unique from the other side of the bridge. Okay. All right, and so if you were able to do that, let's go ahead and do the other side too. And so let's go ahead and do the same thing. And so I'm going to select all the vertices of the beams. Okay. I hit apply. Oh, I missed one. Oh, I missed this one. Oh. There we go. Okay. I'm going to click on this side of the bridge. Okay. Go ahead, hit apply there. Okay. And so that's the other side of the bridge. Okay. All right. And so we need two more. Oh, we need three more. Sorry. Okay. And so the next one that we need is we need to make sure the road itself is connected to the bridge. Okay. And so let's go ahead and right click on contacts, and then we're going to insert a manual contact group. Okay. All right, and so for this one, we're going to click on the left edge of the road. Okay. And so make sure you're on edge selecting mode right here. Okay. And you're going to click on one edge of the road just like that. Okay. Go ahead and hit apply. And then we're going to click on the side of the bridge. Go ahead and hit apply. Okay. And so now that connected that did not connect what I wanted to. Right. And so you want to make sure that you're connecting the side of the road. And so if you see right here, and so what I've done right here is I've connected actually the bottom of the bridge surface with itself. And so that's not right. And so this edge right here on this top side should be the left side of the road itself. Okay. And so I need to make sure that I click on that edge. And so let me go ahead and click on edge selector mode right here. Okay. Let me go ahead and click on that edge. Okay. And that should be right with it. Okay. Right. And so when you click and when you make this contact region between the road and the side of the bridge, right, you can use the two windows here to make sure that it's highlighting the correct bodies. Okay. And so on one side you should have the road, and on the other side you should have the side of the bridge. Okay. All right. So let's go ahead and do that for the other side of the road as well. So I'm going to go ahead and select. If you're having trouble selecting the side of the road, there's on one side of the bridge, the road kind of overhangs a little bit. And so I'm going to go ahead and use that to select that. And then for the surface, go ahead and click the side of the bridge. Okay. All right, and so that's the that's the other side of the bridge right there. Okay. All right, and the last contact region that we need to create is we need to create a contact between the road and all of the supporting beams. Okay. And so I'm going to go ahead and click on manual contact region here. Okay. And then for this one, I'm going to select edge selector. I'm going to select all the beams on the bottom of the road. Okay. So let's go ahead and click that for the contacts. Okay. And then for the other side, we're going to click on the road. Okay. Right. And so now our road here is bonded with all the supporting beams. And so now the beams are going to be helping to carry that load. Okay. All right. I know I went a little bit fast, but I want to make sure I have time to kind of walk around and help those that need it. Okay. But are there any just kind of general questions I can answer before I start walking around?
Should I, when selecting the row, should I just click under the row above it?
It doesn't matter. And so for the road, because we've converted to a shell, now it's a complete two-dimensional surface. And so you click the top or the bottom, it's actually the same thing. Okay. All right. And so, I want to stop here just to have time to walk around. And so if you're on this part with the connections and you're having trouble, go ahead and raise your hand. But if you're still working on some of the stuff from Spaceclaim, you can go ahead and raise your hand too, and I'll come around and help you out. So yeah, so I'm gonna go ahead and walk around for the next few minutes. Measure it, see how far it goes. So you can measure the how far it's moving. So click on just the raw vectors. Yeah. Go ahead and put the bottom of the row. Still got. Is it connected on the other side, or is it just like that on this side? Let's measure this one. Oh. Click on the paint, you click on the arrow to move it out towards the middle. Oh. That's weird. It's weird that it only leaves on one side. Yeah. Is it like that for the rest of the sheet? It's a little bit tough because once you kind of move stuff, then it kind of becomes permanent. Unless you kind of want to mash the undo button, show action. You want to keep mashing the undo button and get back to before you do anything. Then that's probably the best place. Okay, so let's start here. So let's go ahead and hide the road. Looks like yeah, looks like there's one of these that has been expressed. Yeah, so go ahead and try again. Yeah. Yeah, so go ahead and try to run through it again, and then let me go around to other people. You can do one again. Yeah. Okay, so let's go ahead and hide those. Let's go ahead and extend the one that okay. Yeah, it's not that
So we
small.
can see here 1, 2, the first 3.
Yeah. Yep. So let's start with the one. It is great. Okay, so let's go ahead and hit measure. Measure. So let's go ahead and slide it. Okay. So that's 1.9. 1.92.
That's weird. Okay, I don't know, maybe it's a little bit bigger than I thought. Okay, so what do I need to do? 1.9.
Where you guys?
Yeah, 1.93 is perfect. Click on the blue. Yeah. So you want to go towards. Oh, shoot. Actually, it looks like you're. So let's go ahead and just go ahead and.
First work.
Because from measure that
It was still highlighted from before. Yeah. Okay.
So that must be the problem.
Yeah. Okay. So let's go ahead and click. Now it's not. Yeah. I'll go back.
And
Okay.
before you.
So go ahead and try that for the. Yeah, so sometimes so it depends on which word that you use. So we'll talk about this in a few minutes, but typically for the target, you want to pick the bigger surface on. And so the target should be on the target and then
Then it can get down. You know what?
So you're gonna want to change it to. Actually, that's the most. You're gonna click on all of these, those two maps. So you want to do that with all. Statements of the statement. That's one side of it. That's the other side. Probably so those instructions are yeah they're probably oh yeah because I was saying that when I wrote this instruction they were from the different so from a different version probably didn't have to okay yeah no problem. It's all in the video so you know it does actually so the target should be the bigger space. Yes. You can switch them, so you can actually so for the target, and so for in this case the target, you're going to select all the vertices on the site. Take the mouse, once you mouse with the go ahead and so go ahead and we can do one for now, but we're going to do this for all. But you can see right now it's you can click contact person. Okay. So the target should always be the bigger one. Contact. That would be that's the target. Yes, that would be this. Exactly. They just have to be close enough. So it has to be close enough so that you can find these. I'm not sure what the direction will be close enough. Try to get them as close. Okay. Okay. I'm not sure because that's a full millimeter. I would give it a try and see if it's letting you make a contact. Yeah, that's okay. Go ahead and run through the math again. So we should be able to, so I do have some simulation results in the PDF, so it should look. Yeah, so you want to move the road such that it's kind of right. You can measure one of the beams actually. That's one. Yeah. Want them to be facing right on top. So 28.4. Yeah. Or you want to go a little bit less, if you don't want to go, in this case, you don't want to go.
It's the 20.3.
It should be, it should be just the part that. You know,
Yeah.
I did change that, so there's actually. Oh, yeah, I know. Cool.
Professor says that they look up there right on top of each other.
Yeah, they should look like the base.
So like this is.
Yeah, perfect. And so to test it out, we want to extend this, we want to extend the road.
Yeah, I couldn't pay attention, so I was trying to figure out
Oh,
what was
yeah.
wrong.
I have to go at a certain speed just to make sure that. That's why I kind of have to. Yep, all right, you're good to go. Go ahead and close this and then open up. Yeah, that will bring that. Let me go answer questions and I need a rest. Okay. Yeah. Yes. Yeah. So first thing we want to do is we want to measure how far off. The reason they're not connected is that if you look at hard to see, if you look at here, the beams are actually below. And so what's Ansys is trying to understand, but it doesn't actually. The reason we want to move it up is we want to make sure this is not. And so, unfortunately, because this was kind of created a really small loop, then the distance vector we go over each one is different. So for each one, we're going to have to measure how far we have to go. First thing we go to measure. So that's an example. We want to just get.
What up?
Like fucking 1% right now. I'm at 10, but I'm going to the gym later and I need to be able to watch my TV while I do my fucking.
Watch your
cardio.
TV while you do this.
What do you mean one of those? You know how boring it is to be with only your thoughts for 45 minutes when you're walking on the fucking treadmill?
Bro, it's not even why you want to watch treadmill, bro.
Huh? Dude, because my hip is fucked up. I can't do anything else. That's it. I can't do the elliptical. I can't fucking walk on the stairmaster. Nothing.
Where's this trash, bro?
Oh, careful first. So go ahead and click, just click anywhere. Because we want to make sure we.
What is this trash, bro?
Go ahead and click on.
16.34, some kind of fucking joke.
You might want to move the camera.
Oh, bro. So no, wait.
What?
So the mistake I made, you have to unclick before you start. Cause watch, move that thing. Move it. Look, it's extending the side of your shit.
You want to make sure you're going right.
It's adding and deleting to the bridge. Watch, move it.
Okay.
So it adds and deletes to the bridge when you don't unclick it like that. That's why it keeps getting fucked up. I made that same mistake. I was getting really frustrated back there. So you just have to go undo a shitload of times until you get back to before you started moving shit around.
Okay. So now I'm chilling, right? So it's cool. That's all I want to move. Let's go. Right? Yeah.
So now.
Yeah, yeah. But you have to make sure you didn't do that to the rest of your stuff though too.
So you're gonna do that.
Don't say that, don't say that. Say that.
Wait, so your iPhone charges in your car?
Yeah, bro, how important is it?
So it'll.
You can go get it.
It's not close at all. I don't know where your car.
It's already kind of annoying.
Is that east? East spot? The one right here. The
Oh,
one right
bro,
here.
that's super close.
Okay,
Okay, yeah, can I get it after we finish the
because
class?
we
Can
get
I?
that road.
Thanks.
I'll save it. I'll save it. All right. Yeah, so I know this activity is probably more annoying than most, and so this is what I was talking about on Monday. Is that shells and beams are kind of annoying to deal with. But we do have only 10 more minutes left, and so I want to make sure that I cover. I at least talk about what I expect you to do for the rest of the activity. Okay. And then I'll say a bit after class today to kind of help people out, because I know people are kind of different parts. Okay, so once you get through the contacts, then that's all the new stuff for this activity in terms of new features. Okay, and so once you get through the contacts, then problem 2 is meshing, and so that's fairly straightforward at this point. Okay, but I will show you one thing that I think someone will ask me about this anyway. Okay. So let me just go ahead and generate a default mesh here, okay? Okay. And you can see once I've created this mesh, you can see that it created elements that look blocky, right? And so, I think the first impression that a lot of people have is like, what the hell? I went through all that trouble to transform into shells and beams, and now they're gone. But they're not gone. And so this is just a rendering thing within Ansys. And so if you want to remove this, you would have to go to display, and then there's an option right here for thick shells and beams. Okay, and so usually I like to disable this just so that it actually looks like I have shells and beams in here. Okay, but if you prefer to have it on, then that's fine too. But once you mesh it and you see this, don't panic. You still have shells and beams. You didn't just do all that for nothing. It's just that Ansys is rendering it as thick shells and beams, and so you can go ahead and disable that, and then your mesh will be just fine. Okay. All right, and so that's the meshing, and so I think there's nothing too complex there. Okay, and so problem 3 is loads and constraints, and so I've described kind of the constraints that you should have. Okay, I'm going to let you decide on what loads that you want to apply. Okay, but if you want to recreate my own results here, then basically what I did was I applied a constant pressure on top of the road. Okay. Question: so do I have a preference on how we show our meshes? You can do either one, and so I don't have a preference. And so if you want to show it as thick shells and beams, then that's fine with me. Yeah. Okay. And so if you want to recreate my results here, or at least the distribution of the results, then all I did was I applied a constant pressure on top of the road. Okay, and so in addition to the fixed constraints that I talked about in the document, okay, all I did was I added a pressure on top of the road just like that. Okay, and so it should be a downward pressure going down. I don't remember the exact magnitude that I used to create these numbers, but if you get plots that look similar to this, then you're on the right track. Okay. And so that's problem 3. And so problem 3 is just applying the boundary conditions. Okay. Once you apply the boundary conditions, then problem 4 is just looking at your results. And so that's fairly straightforward. And I have a couple figures here for you to check your results just to make sure that you're on the right track. Okay. And there's some discussion questions for you to answer here as well. Okay. And so make sure you answer those. Okay. All right, so problem 5. So problem 5 is a new addition to this activity. So I just added it for this year. Okay. And so the nice thing about this activity is that the element counts are actually really low. And so, because we're using shells and beams, the amount of elements that you have in this mesh is actually quite low. So actually, if I check this now, you can see that I only have 525. And so I thought this is kind of the best, this is kind of as good an opportunity as we can get to learn about how to do mesh convergence testing. Okay. And so the idea with mesh convergence testing is, this is, and we've kind of talked about it a little bit a couple of times in this class, but the idea with mesh convergence testing is that this is a way for you to assess how accurate your mesh is, in terms of your results. Okay. And so what you're going to do is you're going to run your simulation using the exact same boundary conditions. And so that's important. And so don't change the boundary conditions, but you're going to run it with 10 different meshes. Okay. And with those 10 different meshes, you're going to change the mesh size such that you get a different amount of elements for each mesh. Okay. And then for each simulation, what you're going to do is you're going to track, you're going to write down in a spreadsheet what some quantity of interest is. Okay. And for this activity, I'm telling you what that quantity of interest should be, and it should be the equivalent stress, okay? And so I want you to run 10 different simulations on 10 different meshes in order to get a plot like this, okay? And ideally what you should see is that, you know, eventually your, you know, your results are going to change as you change the mesh, and you'll be able to see that pretty dramatically actually with the equivalent stress, okay? Eventually you'll reach a point when when you reach convergence. And so, you know, you can kind of argue once you kind of reach this point right here, and then if you improve the mesh further from here, then you don't really see that much of an improvement on the results, okay? And so this is usually the point where you want to be in terms of, you know, convergence for your results, okay? And so what I want you to find for this activity is what is the point of convergence, right? And so where do you get a converged mesh? And what is the converged value for equivalent stress, okay? All right. And so this mesh convergence test is a fairly standard practice for any kind of you know, finite element report. And so you're going to have to do one for your final report, not for the midterm project. So because I hadn't taught it to you, you know, at the time when I assigned it, but for the final project, you know, you're going to have to do one of these. And so I figured this is as good an opportunity as any to teach you about it, just because the element counts in this activity are fairly modest, you know, relatively speaking. Okay. Okay. And just to note that if you added any refinement during the meshing step, then for this mesh convergence test, I want you to get rid of it. Okay. All right, problem 6. And so problem 6, I want you to change the loading a little bit, okay? Or not change the loading. I want you to change the supports, okay? Because right now, you know, if you look at these results, you know, the way I produced these results was I basically only fixed the bridge at the ends, okay? And that's not realistic because in reality, you know, bridges like this are supported from the bottom as well, okay? And so for problem 6, I want you to add some additional fixed supports, or actually I think they're displacement supports, okay? And then I want you to rerun your simulation, and I want you to kind of see, you know, how that affects your results, okay? And so, you know, for this activity, since there was kind of a lot going on already, I didn't want you to think of, you know, 3 different loading scenarios. And so I'm giving you kind of the extra boundary condition scenario that I want you to cover here, okay? And so all you have to do here is, you know, highlight all of these locations in your model, add a displacement support there, and then, you know, rerun the simulation and see how that changes the results, okay? Problem 7, what I want you to do for this one is I want you to run the simulation again, but with just the base geometry. And so, you know, without converting anything to shells or beams, I want you to run the simulation with that and then compare what you get with the shell and the beam results, okay? And then problem 8 is the standard that we've done up to this point is just a quick 1-page summary of all your results, okay? Okay, any questions on the rest of the activity? Okay. Yeah, so I know it's a lot, and so there's a lot going on with this activity, and so that's why I gave you kind of an extra week to do it. And so, you know, definitely, you know, try to get as much done today as possible. I'll stick around for the next, you know, 15-20 minutes helping people out. But, you know, try to kind of, you know, work on this steadily over the next 2 weeks. Okay. Question. So how do I convert everything back to Spaceclaim? Yeah. And so I think the easiest way is to make just a new project. And so with the new project, you can just reload the geometry in and then just jump into mechanical. Yeah. I think that's the easiest way instead of so one thing you can do is you can just mash the undo button in Spaceclaim, but I think it's better to kind of have just 2 projects for that. Okay. All right, any final questions for the overall class before we wrap up for the week? Okay, all right, and so I'll stick around for the next 15-20 minutes. And so if you need my help with anything with the connections or with the geometry, just go ahead and flag me down. But if not, then I don't want to hold you guys past the time. And so thank you everyone for tuning in today. I know the activity was kind of a lot today, but you know, thank you guys for your patience, and you know, hopefully it's you enjoy the results. Okay, so have a great weekend, everyone, and I will see you next week.
Oh,
Let's get it back to the state before you. That makes sense. So. That one is that. Okay, let's get it back to. Let's go ahead and measure the. Just don't add any. Try. Oh. Yeah, I think probably. Or you might just move one head. Unfortunately, it's just hard to use that. But still, until you get to the stage, because I think the beat is let's measure the two. So it looks like just one thing of the beat. So I think either it's a little bit hard. So, yeah. Yeah, go ahead. My whole
hold it, hold it, hold it, hold it up. And you can kind of zoom in. It is a- No, no, we just want to keep it. Okay, go ahead and specify that. Okay, and we want to connect this to the side of the bridge, so go ahead and change this to the base selector. No selection. Yeah, perfect. And so what you can see here is that you have all of these sides of things, and they're connected to this side. And so you're going to repeat that for, you're going to make a new region for this one. You're going to do the same thing. So go ahead and hit the select. Yeah, so it's yeah, you're gonna have to select this thing. So go ahead and just click on it's right by you. So let's go ahead. Okay. So let's go back to and then so I'll do that. Okay. So, yeah. And, you want to move it. Yeah, you want to move it. You want to move it up towards the because the horizontal distance we're going to get that extend. We want to get control. We want to make sure that that there's an intersecting. You want to make sure that the entirety is good. And so we want to move this so that's the number that we can forward. And so we want to move it upwards because right now the issue is when the Ansys tries to extend this, it doesn't intersect. We want to move this up into 5. So we want to move up a little bit, and now you can see that now this will go like this. So we go to here. Now when Ansys tries to extend this thing, it says, okay, now I can. Yeah. The side of the road is a little tricky. Yeah, so it's a little bit hard. So the best way I found is the boat actually hangs over the bridge on one side. Yeah, so you can go ahead and select. I click on this wheel. That's this side of the bridge. So you want to put your mouse. You can zoom in a bit. Yeah, perfect. Okay. This is the contact. Target should be the side of the bridge. Yep. Yep.
Yeah, you know what I mean?
I think you. I'm gonna go check our phone. Everyone else? Good? Okay. Okay. Yeah, you can this. It happens like that. Still happens. That's fine. It's just it was you're able to get context between the fluid and it. Okay. Yeah, so go ahead and apply because it has to because they're right up to each other, then kind of looks like it's poking them out. Okay, let me talk to you first.
It's not, I think this cannot seem to like, apply the meshing method to the geometry stack. And I try to.
Yeah, so you have to do it based on this, and so when you select, yeah. So it's and so let's go ahead and click on the side of the bridge because the method only works when you select that. So go ahead and click on that now.
So
yeah.
Oh, so when the thing transforms to shells and beams, you can like select matches.
So when you're doing methods, method only works when you do formats, and so you need to make sure you're in that one. But the shells and the beams here count as like even though they're kind of 1D surfaces, 1D or 2D things, and so yeah, in order to get to more with that,
And so when do you use Spaceclaim and when do you use design mode?
So Spaceclaim, the reason I'm using it for this one is because it's a little bit, believe it or not, it's a little bit easier than design modeler to do shells and beams. Just because it's very more design modeler is better for like more precise stuff. And so, yeah. And so I think it's activity 7 that we're gonna do, or maybe it's 6. We're gonna learn about how to do optimization, and that's a lot easier to set up in design.
So it's just like you can choose.
Yeah, it's a lot of it's personal preference. And so a lot of things you can do in design modeler you can do Spaceclaim too, and vice versa. It's just that for shells and beams, I prefer Spaceclaim. So that's what all the documentation is written in. But I know you can do both. And so this was also kind of an introduction to Spaceclaim for.
So that's
I see. Thank you.
Yeah.
oh. Is this right? Because before I had the contact and the target switch.
Yeah.
But there was a question.
Yeah. So for the contact and the target, it seems like it shouldn't matter, but it actually does. And so for the target, it should always be the bigger of the surfaces. And so since the really bigger one, you should have that as the target, then the contact is just the same. So if it detects that, then I don't know why it just doesn't switch it automatically, but you can switch it.
Is there anything special on the machine here? Or?
Not particularly. And so you can actually, you can do most of this mesh. And actually, for my results, I did it from the mobile settings. And And so I know in the activity it said they add methods and stuff like that, but you can change the entire size of the mesh here, you can change the order. Those are the two. Yeah, there's nothing special. You can turn this on. So if you go on. Yeah. And so go to display. And so Ansys does this automatically because a lot of times you're going to mix shells and beams with like an actual 3D part. And so this makes it look like it's all the same. But I usually don't like it. So you can turn it on. So now you're not. But you can do whichever one.
Thanks, Professor.
Yeah.
I got started.
Oh yeah, California, it's next week, huh?
Yeah.
So,
Really strict.
but apparently that was the vote, right? People voted for.
Yeah, I guess, but like only a little bit more than half the class voted because some of us didn't have access to them.
Oh.
So maybe because we were signed in wrong or something like that.
Yeah, no problem. See you guys. Have a good weekend.
But she said it didn't matter what the vote was anyway, because there's, I think, 2 or 3 students in the class who have a midterm on the 26th too, so she didn't want to make them take 2 midterms on the same day.
I mean, you can probably say the same thing, though. Probably some people have midterms next week too. So,
Yeah, I mean, like I have jury
um,
on the day of the test, so I had to like call in and get it switched.
I mean, there's never going to be a perfect date, but usually I set those at the very beginning of the semester. And then only change it under like emergency circumstances, just so you can plan ahead. That's my.
It's okay, it is what it is. I mean, it's like, I would have rather had like 2 months to study for this exam, but like, I think that should.
That's the work. I don't envy your position at all. What's up?
I'm trying to add a mesh to the beams.
Yeah.
Am I supposed to be able to just select them here? There's no letting me.
Doing the method, yeah. So for the method, I think the tempting thing is to select edge here,
Mhm.
but then for methods here, you can only do it for bodies. And so you can actually select the beams if you click bodies. So these are actually like 3D bodies, but they're 1D and 2D objects. And so
It's gonna let me select them?
So probably the easiest, the simplest thing is to hide the road. And so if you go ahead and geometry right here, I wrote that one, so and right click, just hide it. And so now you can click that. Yeah. But I was telling Jacob too that I know in the activity that I said to create these separately, but for this activity, I find it easier just to kind of just do everything from the bulk one. And so, the only thing I'm having you change in this one is just the element size and the element order. And then, and that's really all of it. So you want to make sure that you're quadratic here. And then this size is going to change. It's going to change the size for the.
Yeah, I took it at the city college.
If you want to do this, this is
I'm kind of wishing. that
this
I
is
was
a-
here
you
because
want to do
I
one less
just
than that.
totally
Yeah. And
forgot.
so this is perfectly fine for this activity because there really isn't anything special with the mesh I want to do here. So there's already enough to do with the shells and beams, and so with the mesh, makes it more
Yeah, I think
complicated.
we sign up
So you can go ahead and delete this.
professor,
Okay. Fair enough.
Yep. And now you can just generate that mesh.
You know what I'm talking about? Well, they're teaching real
Yeah, and especially for the mesh convergence test, it's going to be easier to kind of change from here instead of changing each side individually. Yep. You can go ahead and show your surface again too. Just see the road.
Is there any, I can't like pan properly.
It's you have to hold control and then hold the middle mouse button. It's really annoying.
The whole time I was going like this.
Yeah, it's annoying. I know.
Okay, fair enough. Yeah, I don't know the hotkeys on here, so like when I want to do like an ISO view or something, like I have to like.
If you want to do ISO, it's the blue ball thing. Yeah. And then you
Is
can
there
do-
any like where I can just switch ortho? Like usually it's.
Oh, that I
control
don't
to-
know. Yeah, I know you can do that in SolidWorks, but in Ansys.
It's just I do it and like nothing happens. and I just get frustrated.
I know when you're switching from one software to the next, you're used to it, and then
I
The next
literally come
software
from
is
work and then I'm like, it really is, I don't even think about it. I'm using SolidWorks and then it's just this shit. Okay, so we are not doing the method.
yeah. So yeah, you just control the mesh here. So I will say you're probably going to want smaller elements than
Yeah,
we
I
have.
just realized that.
And then, but besides that, yeah, just play with the size. Just make sure you're quadratic and you can change the size to what you want.
Okay,
Yeah.
thank you.
Yes.
We
Can I
don't
run the other room instead of the
We don't want to move this one.
we don't have time to call, but we're gonna have to go.
Oh, for real? You know, it's in the flat lot, right? There's not that much park there.
Pretty good.
You wanna give it a shot? I mean, I come with you, dude, as long as like people don't bounce and they can do that stuff.
Yeah, well, I mean, we can just ask
So that's. Oh, and now you're ready to.
just leave the trash can.
So how come you need us to do that?
What do you mean?
He doesn't want us to do a method, right?
So
He
yes,
just
the
wants us
way
to do a
you
method.
sync is that.
So we don't have to add a,
Oh, yeah, we just alter it right there from the global settings you said.
yeah,
Mhm.
just put quadratic.
That's
and
what
then
I
just-
did, is to use.
Where's my fucking mesh, bro?
There's our-
Yeah.
Because with our time, it's gonna-
Oh, where is Oh, no, you have to go to display
So if you try to do
No,
save,
bullshit.
it's gonna save,
and then
it's gonna save the project file.
you have to, it's somewhere up here.
Yeah, I
So
know.
I always find.
Yeah, it's happened to me a couple of times.
No, no, no,
And then it's.
Oh, there it is right there.
It's a shitty looking
Then
mesh.
the archive is just gonna save it all in one file. And then you can just put that one file. You can email that for
This
yourself.
is trash. It's absolute trash.
What do you think? You want to set it to like 9:30 or 10?
Dude, I'm stressed. I need to do it. I mean, I'm so much stressed. I need to
So it's gonna take you to the basic maps that-
No, yeah, but I'm saying you wanna. What
You have to have a safe
9:30 or
spot.
10? I'm thinking
I'm
like
thinking-
two, I'm thinking like 2 or 2.5 hours.
Of class and six.
Yeah, it's not it.
Yeah, I'm probably thinking tomorrow, bro.
Because I'm gonna put this on the back. burner.
It should be okay, because it's,
I'm gonna have to. I just want to mesh it in that.
Yeah.
But
Well,
I would
Yeah,
say
this
it's one
point,
more time.
I'm not gonna start the project until the next week.
Yeah, I mean, same.
You know what I mean? Like, it's like Tuesday, you finish the test, you Friday. That's
It
it.
should be.
Although,
So you see
dude,
the
I mean, like, at this rate, like, I'm just
This
gonna
is the
run out
one
of
that
practice problems. Like, dude, there's not a lot in the book.
Bro,
That's the only.
you're gonna be fine if
So the
we
other one,
rework
that's gonna be
most of the homework.
Because, so when you open this one, it's.
She said the test problems are gonna be different. Like,
Bro, it's
the
not,
whole
it's
point.
what it is, it's like, it's just one problem taken and added,
And you can just
like,
override.
just have the concepts added in. Oh,
And so when you open it,
do your definition of all posture. She's gonna be like, think about it. Here's the transfer function, right? Take the transfer function. Put it in terms of what that's about, and then select it, and everything out from that.
you've done everything you're ready.
Show that it's safely interoperable to whatever, which might be like, here's a matrix.
Yeah.
State-
it's a little bit.
state to
So
state,
there's,
right?
'cause right now.
And then from the state, like, should combine.
Uh,
It's not,
because
it's gonna be homework problems, she's not gonna give us 5 problems, like that are all like you have to work out, it's gonna be combined homework.
Okay, yeah, but I mean, like, I like to do practice problems. That way if Sharon decides to put us in a different
Well, we can do the
situation.
additional problems, but the answers on those, I forgot.
And so what's the.
I don't even know. I don't even think so.
So you have to.
Like, I
If
don't
the
even-
answers are not on them, then
So
it's useless.
usually you just have to, you'll see that.
I remember her putting the answers.
So you have to
I,
define-
I really hope they're there. Because if she did not put the answers to those additional problems, like, I might just fucking have a brain aneurysm.
But I think they,
It's a
even
problem.
though the lesson doesn't put the answers to the original problems yet.
So nothing gets hacked.
So
That's the most valuable part of the check.
they're gonna practice on their additional problems.
Yeah.
Yeah, but we don't have the answer yet.
Maybe not, they're not on there.
Dude, that is so frustrating.
Make sure you email it.
Yeah, well, what am I gonna do? Oh, wow, I think I did.
If you have questions, you can come by.
You guys are all ready, I'm gonna be right back.
I'm heading out soon.
I'm like leaving all my stuff there, so, yeah, it makes it.